Hi again, this is Javier Orozco once more, and I'm going to introduce you now the sub-module for life cycle analysis within the overall module for the physical transition in the Essence blended learning course for sustainable future sustainable cities. Thank you very much. So please let's go into the details. Obviously, life cycles analysis is considering all the different options and needs for our buildings, for our city, through the entire life span of them. Life span of a city is huge. For example, in the case of Valencia, it's over 2,000 years, and we should carefully introduce what concepts and definitions we should be taking into account for this analysis. Then see what the standards and databases are available, which can help us in that design, and implement a solution for modeling these future smart sustainable cities. Let's go into the detail. First, what's life cycle analysis? According to the ISO standard, it is a method for analyzing and determining the environmental impact along the product chain of technical system. It includes different conversions, technical problems, and manufacturing processes implemented through the life of the building. And of course, are including the change of material chemistry, energy, basically removal of different materials and assembling all of them. So all in all, and according to the ISO 14040 standard, we have the formal definition. LCA is a technique for assessing the environmental aspects and potential impacts associated with a product, building, city, or through a compiling inventory of relevant inputs and outputs, so balance, inputs, outputs, and processes, evaluating the environmental impacts, so those emissions which can be dangerous, and interpreting the results for being able to compare different solutions onto sustainability. Here we have all the different elements which are to be considered in a city, according to the product lifecycle design by Stachowicz in 2001. So, materials are to be considered from their raw state through manufacture, trade, transport, uses, and final recyclement or eventually waste management. All these elements are the basic inputs for the basic chain elements in our LCA analysis. We have energy, embodied energy, which is included. We have different effluents, outputs, which are or could be dangerous to the environment, and we included distinct work or transport elements which come into use into the embodied energy of the material. The quantitative LCA methods, according to the standards, are eco points, eco indicators, EPA system, mixed concept. In our case, we will provide a balance which will provide a possible evaluation on eco points and eco indicators. Other techniques, apart from these ISO standards, such as LEED, provide different solutions, but all of them begin with this careful balance of what's happening in the building. Once we have the different elements, we should be weighting each of these elements and obtain, through the weighing, a final result for the overall sustainability of the system. Here is where we can change, and the different standards are implementing possible interpretations for sustainability. And this design is basic and should be agreed internationally in order to have only one scale for sustainable performance. Again, the improved assessment includes certain uncertainties that we cannot really cope during our design process. Basically, the use of different databases, the not consolidated origin of data is a big problem, and the detailed report is necessary in order to compare the overall feasibility of the results of the analysis we want to perform. Then we can either introduce the indicator methodology, where through a multi-design process we obtain environmental loads and are weighing all of them in order to provide a final evaluation of the building and add it together to the city. Here you have some important databases like the 14,000, the one we will be using, LEED certification, cradle to cradle, or the 5-layer procedure developed by Mike Ashby at Cambridge University. We have supporting databases for materials, and we have finally certification. Certainly this absence of a unique evaluation is providing really a difficult approach to sustainability. We will go for the ISO standard, but certainly please consider all these other options, and we will try also to see how they converge and how they give different solutions, because typically ISO standard is product-based and so more isolated from the building level. LEED is more onto the LCA, the material approach. Cradle to cradle is more process, and 5-layer tries to compensate and bring together all the different standards. Finally, there is no one solution, and the overall check of results will provide us with different approaches which we can compare and make our basis for selection. Again, this implementation at city level for architectural design has to consider not only the building level, but also all the different elements through the life of the building, and including the performance at city level. For that, there's an independent ISO standard which provides the 18,000, which provide us with solutions for measuring, for example, net zero energy, or providing different indicators of what is and what is not a smart sustainable city. This is also included as part of the BIM model, and we can then compare different indicators and provide our own desired and agreed image on what's a future sustainable city. Finally, the BIM model, taking into account the reality of the building, following, for example, the open house approach and the different databases for materials, is going to provide us with the overall result, the overall design that should be recycled, renewable, efficient, safe, and social. Those are the criteria which will define and will allow us to evaluate in perspective all the different elements of the BIM model and its result. Here we have the different parts, market needs, embodiment, detail, but this life cycle design finally will produce indicators which are to be compared and provide a full LCA analysis of the building. The redesign, once the full LCA is performed, is very desirable in order to make an optimization of the overall building design. For cities, that's different, because for cities we'll be obtaining eco indicators that can only give us a time evolution on the sustainability of the city. So the actual implementation of policies through BIM models, through LCA analysis of all buildings, will be checked against these indicators evolution in the overall city model. The steps we should be then include in this analysis is first divide the process in logical stages, from building, construction, use, and final disposal of materials. Determine which energy criteria are really relevant, meaning should we include the use of a lot of renewable energy, because all in all energy can be cheaper and less damaging if we don't consider, for example, they will eventually disappear if they are not renewable. Again, we have to ponder materials and the different processing steps for each of the elements and for each of the phases in the life of the building, and then compare, as I said, the solution and see how sensitive they are on specific malfunctions of the system. Examples that we can check, for example, in a multi-story car park, the most important phase is the manufacturing, actually the materials that are used in the building of these parks, because they don't use energy at a later stage. In a private house, that is comparable to the actual energy use that we have during the life of the building. Here we have different sustainability analysis of this example of an old alquería near Valencia in Sagunto, where the different solutions can provide up to 35% saving only by choosing rightly the material. In more typical flagship projects like this house designed by Le Corbusier, we obtain the integration of a bigger number of elements, including where it's located and the actual origin, for obtaining a refurbishment solution that gives us a very good performance through this sustainability check. Other possibilities, for example, if we are to use passive system, like this shading of the different glasses is important, or even go at bigger level, like in the Masdar net zero project within a desert, which seems to be quite difficult for a net zero project. Again, thank you very much for joining us in this submodule, and please try to follow all the exercises for completing your learning objectives. Thank you very much.